Welcome back. Today we're going to be looking at the Robo Pico in detail and what my thoughts are about the new expansion board from Cytron. So let's flip it over for a second. These are the 4 stickers we received in the box and I've already installed them on the back. This is the screwdriver that we received in the box from Cytron. These are the 4 Groove 2 female jumper cables that we have. This battery is not included in the box. I just brought it to show you how we can use it with the Robo Pico. You also need to separately order the Raspberry Pi Pico or the Pico Wireless if you are going to need internet or not based on your project. Be careful about the orientation of the Raspberry Pi Pico when you're installing it on the expansion board. I totally missed the information provided on the expansion board where it shows the USB icon on the left. So this is the terminal where you can attach the battery, and there's an on and off button switch on the board. Right now the Raspberry Pi Pico is not installed, so there's no program running. Let's go ahead and attach it to the board. So you can just put the board on the desk and then try to push the Raspberry Pi Pico in so that you can push it equally from all 4 sides. That's it for this time. We will come back and program the Robo Pico in the next session. Welcome back. Now we're gonna power on the Raspberry Pi Pico with a USB cable. You will see that it will run the default program that is already there. After we connect the cable to the Raspberry Pi Pico, we will see that after we connect the battery to the battery terminal, it will not start charging it right away because we've already powered on the Raspberry Pi Pico. So you have to either turn it off and on again to see the red light show up for charging the battery, or you can simply attach the battery before and then power on the Raspberry Pi Pico with a USB cable. This way you will see it charging. Now we're gonna head over to our computer and connect our Raspberry Pi Pico to the Thonny editor. And in the Thonny editor, you will see that if we open code.py, it has a default program. What we're gonna do is we're gonna make a copy of this program and make a new file called default and put it right inside the Raspberry Pi Pico so that we can use it later if we want to. Now we're gonna delete the code from code.py. I made a mistake here where I deleted from the default.py, but instead we have to delete it from code.py to clear the program. And this will give us a clean slate to start testing our Robo Pico with our Raspberry Pi Pico. So we're also going to reference the CircuitPython documentation from Adafruit's website. So now that you can see we have already got the firmware installed, we'll head over to the browser and open the website to get some reference for what we want to do with our Raspberry Pi Pico. So the first thing that we're going to take a look at is the Raspberry Pi Pico wireless examples, which mainly focus on internet related stuff, where you have examples to run a server or do other stuff. But for our case, we are interested in understanding how to use CircuitPython in general, especially the I/O part of it with the Raspberry Pi Pico. So let's head over to that section of Adafruit's website. If you're new to CircuitPython, this is a very good resource to start learning about how to program with the Raspberry Pi Pico. And this section will teach us mostly about the basics of programming, not actually operating anything on the microcontroller itself. But the next section, where it talks about the pins and modules, that's where we will understand how to use the I/O pins of the Raspberry Pi Pico to do stuff. So the first thing that we're going to focus on is the board part. So what the board command or the keyword allows us to do is kind of get a reference of all the input and output pins available for this specific board. And if we follow the instructions from the documentation, we can see that we have a lot of analog and digital pins inside of our Raspberry Pi Pico itself, which we are going to utilize from the expansion board of Robo Pico. And it also introduces how to use the different protocols, I2C, SPI, and UART. For us, we're just going to focus on the digital pins to kind of get into understanding how these pins are connected to the expansion board itself. So the main thing that we are going to take a look at is the digital I/O module, which is a built-in module inside CircuitPython. It will allow us to manipulate the pins from our program. So what we're going to do is we're going to assign a temporary variable LED, and we're going to reference one pin at a time and try to turn it to the high value, which will turn the LED on the board. So we are going to start with the GPIO0 or GP0 here, and we are going to turn the here I made a mistake because there's no digital I/O module imported yet, and we are running it in the command line, so we actually have to import it before we can reference it. Now we've already referenced it. The second thing we're going to type here is the direction of the pin. We are going to use it for output, so we are going to assign it to be output instead, and then we are going to turn it to true. I think I made a mistake. It should be a capital T here, so let me check back on the website. Yes, it's supposed to be capital T. So once we do that, we can see that the GP0 has been turned on the expansion board. Now we're gonna repeat the process for GP1 and GP2, and the rest we can just do them later, just to get a feel of how inline these ports are connected. Let's compare these two boards. One is the Maker RP2040, which has the two vertical groove ports, and the other one is Robo Pico with the two horizontal groove ports. The Maker RP2040 LEDs are all together, which is easy to debug. This one has the RP2040 onboard chip, and the other one has the separate Maker Pi Pico. These LEDs are sandwiched between the header pins and the groove ports, so it makes it difficult to understand whether they represent the headers or the groove ports, so I find it confusing sometimes. That's it, guys. Let's wrap up this video by turning all the LEDs on the expansion board on. The reason why I do this with expansion boards is to understand how the I/O pins have been mapped to the board. Sometimes they're not in order. Just as an example, on Robo Pico, the pins are mapped on groove ports from 0, 1, 2, 3, 4, 5, and then you jump all the way to the last two, second last and the last one for 6 and 7. And Others also have 16, 17, 26, 27, and 28. So this will allow you to understand what pins are available on Grooveport, and using the pin out card that they send in the box, or using the pinout diagrams online, you will be able to understand which groove ports you can utilize for different protocols. The pins 12 through 15 are used by the servo, and the pins 8 through 11 are used by the motors. The pin 22 is used by the buzzer, and the pin 18 is used by the two NeoPixel LEDs. And the pins 19, 20, and 21 are not referenced on the board. Alright guys, I hope you enjoyed this video and it will help you to program the Robo Pico and have fun making projects with it.